Alright, so here's some really cool stuff coming up, and we're talking about area of triangles and law of science. First off, we'll talk about areas of triangles. Now, to find the area of a triangle, like before, when we've been working on this, this is right angle trigonometry. Now, this is not necessarily a right triangle. We just drew an altitude for the height. So the area of a triangle is 1/2 times b times c times sine of a, or 1/2 times a times c times sine of b, or 1/2 times a times b times sine of c. And that's actually just the area of a triangle. It's really cool how it all works out. So here's the formulas for it. Now, someone did something crazy. They said, what if they all equal each other? And then we divide by 1/2 ABC. What they accidentally came up with, not accidentally, but kind of purposely came up with, is the law of sines. And the law of sines states that any triangle, and this is not right triangles. Last time we talked about just right triangles. This time, any type of triangle, the sine of A divided by A is equal to sine of B divided by B, which is equal to sine of C divided by C. So I can basically find any angle and side length of any type of triangle that isn't right. Or it could be right, or it could be obtuse, it could be acute. It's totally up in the air. And law of sines is a beautiful theorem that does that. Okay, now law of sines can only be used when you know the measurements, the two angles and any side, or two angles and an obtuse angle opposite from one of them. That's hugely important to know right there. Okay. All right. I like to call that the SAS, or the SSA theorem. Okay, now if you remember in your geometry year, you probably noticed that, oh wait, we can't be working with that. That's not congruency. Well, we're not dealing with congruencies. This you'll investigate further in trig and pre-calc. Okay, but this will not always rain on your parade all the time. Okay, so SSA, it's not really that scary, but it is a little bit freaky when you work with it. Okay. Alright, so let's deal with some actual measurements. Let me get some. Let's go to examples. Okay. Alright, so as we work with this, okay, let's say that this angle is 85 degrees. Obviously it's not, because my drawing is incredibly horrible. The measurement of angle R is 54 degrees. Okay, so let's say that this one is P, R, and Q. Alright, and we know QR is actually 30. This has a length of 30. Okay, so these have all been tested out to work. So what I'm going to do is I'm going to find this one, which is PR, by just using the knowledge I have. Okay, so first off, I know that all the angles inside of a right triangle should add up to or any kind of triangle should add up to 180. So I'm going to go 180 minus 85 minus 54, and this angle should be 41. It's not looking like it should be in this case, but it actually is. Okay, so what I'm going to do is I'm going to use some ratios from the law of sines to actually set this up. So if you notice, there's three equations that are equal to each other. I'm just going to use two of them in this case, and you're only supposed to use two at most at any time. If you have three, all three being used, you're going too far. Okay. All right, so what I'm going to do is I'm going to use this pair right here, and then I'm going to use this pair. Okay. So I'm going to have sine of 41, all right, and that's going to be over the question mark. I'll just name that x. Okay. All right, and then I'm going to have sine of 85 and have that over 30. Okay. Now that I've set up my proportion, I can cross multiply. So 30 sine of 41 is equal to x sine of 85. Okay. Now what I would do is I'd probably divide both sides by sine of 85, because then I would have x alone, and that's perfect. Okay, these two will simplify just to 1. And guess what? I just use my calculator. I make sure it's in degrees. I put that in parentheses. 30 sine of 41 divided by... And if you do it wrong, it will tell you. Or, well, you should be able to use some common sense to actually tell that it did it wrong. But if you do it really wrong, it will tell you. So 19.76 equals x. And so I found the missing side length just by knowing that piece of information. Now, do I need to fill in some other gaps as I work? Yes. Most of the time you'll have to use the triangle sum theorem to actually get this angle right here. But other than that, it's really simple and just really easy to work with. Okay. All right. That's it for the area and laws of sines. Just remember, set up your triangle, then set up a proportion, and solve it, and it just becomes easy peasy lemon squeezy. All right.